So here we go, unit vector notation. And this is a math lecture, basically. All right, so if we have a vector, let's use our vector. Let's call this our vector A. There are two ways to represent a vector, or two good ways. Right. The first way is by with magnitude and direction. Right. So if you can tell which how long the vector is, right? That's the magnitude, and for vector A, we'll label the magnitude over here. How long the vector is and the direction would be the angle. We'll call that theta A, the angle that this vector makes with the x-axis, with the positive x-axis. That's always how, unless we have a very good reason to define it otherwise, that's always how we're going to define our vectors. So the direction of the vector, you can tell the direction of any vector by giving the angle that it makes with the positive x-axis, any 2D vector. All right. And you can take a moment and just kind of think about that. If you know what direction it points, if you know this angle, and you know how long it is, if you know the magnitude, then that completely specifies the vector, right? There's no ambiguity then. You know exactly what vector we're looking at. So that's the magnitude and direction way to specify a vector. The other good way is with components. And the components would be the x and the y components. So ax and ay. And on this diagram here, ax would be this distance, and ay would be this distance. And if you know the two components, if you know the x and y components, then you completely know the vector as well. There's no ambiguity there. You have it fully specified. Right? If you know how far to the left or right the vector points and how far up or down the vector points, that's all you need to know. And we're going to find it's going to be useful to be able to switch back and forth between the two ways of representing these vectors. And we use trig. Why do you think we use trig to switch between the representations?
Triangle.
Yeah, it's a triangle, right? It's not just any triangle.
The right triangle.
Right triangle, right? And of course, trig is all about right triangles. Okay, so we haven't looked at the unit vector part of this yet, but it's important to know about any vector. You can represent with two numbers, either the magnitude and the direction, or the x and the y components. And actually, it's possible for you to know any two of those. You might know the x component and the angle, and then you would still be able to figure out the other two. So the reason we use unit vector notation it's the way to write a vector as a single mathematical object. that can be used in equations. If you took physics with me, honors physics or CP physics, we had two different sets of equations. We had equations for when we did projectile motion, we had different equations for the x direction, and we had another set of equations for the y direction. But with unit vector notation, we don't need to have separate equations. We can put everything in one equation conveniently. So there's two important things that we need to define. We're going to define two of our unit vectors now. The first one's called I hat. That's how we usually refer to it. Lowercase I with this little triangle above it that looks like a hat. Maybe. And that's just a vector of unit length. So magnitude is 1, pointing in the positive x direction. Right? And that's always going to be the case. I hat is always going to be pointing along the positive x-axis. It's always going to be a unit vector. We always use a hat to signify a unit vector. So the other one, j hat, and remember this 3-line symbol means defined. It's equal, but it's actually defined to be this.
Steven's saying he keeps getting kicked out of the class for some reason. I don't know.
Oh, is he? Okay.
I don't know what's going on there, but apparently that's what's going on.
Okay. Well, yeah. If he drops out and comes back in, I can let him back in.
Oh, he got kicked out again. He keeps saying.
Yeah.
I can give him notes if he needs some too.
Yeah, but I'll let him back in when
I keep like it keeps like lagging really bad, and then I get kicked out, and then I come right back in.
Yeah.
Like everything's frozen, and then I just get kicked out, and then get put back in.
If you have if you have other stuff open, that could be one reason. If you've got anything else open besides Zoom and whatnot. Otherwise, just bear with it. This is being recorded, so you can you'll be able to go back and get anything you missed. All right, and Juliana too, so she keeps getting kicked out. All right, yeah, we'll see if we can. I don't know what we can do about that. But we'll keep going, and if that keeps happening, not just today, then you can always send in a ticket to the student help desk. But I'm not sure what.
It's just been happening today. I think my Wi-Fi is just acting up today.
All right. Yeah, and then the other thing to do, I've noticed that mine lags a lot when I have other things open, a lot of stuff open in the besides Zoom and whatever I'm using. Okay. So j hat, that's another vector of unit length. We know it's of unit length because it's got a hat on it. But this one points in the positive y direction. So that means any vector. So if we have our kind of generic vector A with components AX and AY, that can be written as that vector A equals the x component times I hat plus the y component times j hat. And that's an important piece of this. So if you know the components of the vector, that's how you can write the vector as one mathematical object, and then you can then plug in to an equation. So it's the x component times a unit vector in the x direction, right? So you're taking the magnitude of the x component times the magnitude of 1, but the I hat just makes it point in the x direction. And AY is the magnitude of the y component, how long the vector is in the y direction, and multiplying it by j hat makes it that piece of it point in the y direction. We can also use unit vector notation to write a vector if we know the magnitude and the direction. We can write that vector A is going to be equal to the magnitude of A, right? And the absolute value sign also means magnitude, right? That's the length of a vector. And it's pretty similar to absolute value in one dimension. And we would put that in the r hat direction of A. Where r hat is the unit vector in the direction of A. And to put that in terms of things, to put that RA hat in terms of things that we've already defined and we already know, and you can find, and I'm not going to prove this, but you can check with trig. That's always going to be the cosine of your angle times I hat plus the sine of your angle times j hat.
This came up on the homework too. So is cosine always going to be with I hat and sine going to be with j hat?
Yeah, as long as we stick to the convention that our angle always is the angle the vector makes with the positive x-axis. Right, because in that case, you can see if the angle is 0, then the cosine of 0 is 1, so it's going to be completely along the x-axis.
Yeah.
Right? And then if the angle is, say, 90 degrees, it's going to point right along the y-axis. Cosine of 90 degrees is 0, so there's no I hat component there. So yeah, as long as this is always going to be true and always going to be useful when the angle is the angle the vector makes with positive x-axis. That's why I kind of try to, as often as is possible, make my angle the angle with the positive x-axis. Because if you can because sometimes it can get hard to figure out what angle are we talking about here. Is it going to be sine? Is it going to be cosine? But if you can, as much as possible, stick to that rule, then you can always just use this. So let me just plug this into here. I wish I had one more. Actually, here we go. Taper magically elongates. So we get, we can write vector A as the magnitude of A times this piece here. So times cosine of the angle I hat plus sine of the angle j hat. I'm going to put a box around this one. And so these two ways, these two are two different representations of the same vector, one just using the components, and this one using magnitude and direction. Should label this. And I'm going to go, and I should have put it up here just because we should be super clear about that. I'll put up next to this that theta is the angle that A makes with the positive x axis. I got everything. That's cool. So that's the end of the unit vector notation math interlude. Are there any questions about this specifically?